Hey everyone, Mr. Fugay here, and in this video we are going to talk about a simplification technique called rationalizing the denominator. So this topic may or may not be a review for you based on your prior math classes, but nonetheless we're going to go through a couple examples. The purpose of this skill is that this is a simplification technique that allows us to work with radicals inside of fractions. Preferably, we don't like to have radicals in the denominator. It makes working with fractions much more difficult. So one of the strategies and pieces of advice here that we're going to use is anytime we get an answer for the rest of this course where there's a radical in the denominator, we're going to want to simplify that. The process is very simple in terms of what you do, but sometimes there's some properties and such that we have to remember. So we're going to go through a few examples in this video. So on the side there on the right-hand side, I have the steps that we need to do to rationalize. So we're going to look at number one. So it says identify radical in denominator. So the radical that we need to work with here is the square root of 10. I do not want to have the square root of 10 in my denominator. And so what we're going to do is what step 2 says. We're going to multiply both the top and the bottom of the fraction, so the numerator and the denominator, by square root of 10. Now, the general rule of thumb is when you're multiplying numbers that are radicals and some that aren't radicals, the rule of thumb is you multiply radicals with radicals and non-radicals, or numbers, or whole numbers, coefficients, whatever we want to call them, with numbers. So you're going to hear me say in this video over and over again, multiply radical with radical and numbers with numbers. So in this case, in the denominator, we're going to get the square root of 100. And this is going to, what's about to happen in the denominator will happen in every example, which is exactly why we're doing this strategy. In the numerator, we're going to get 5, which is a number, root 10, which is a radical. They're not going to be compatible, so they do not multiply together. So what happens is whenever you rationalize and you multiply a radical by itself, what you're always going to end up with is a perfect square. And so instead of writing the square root of 100, what we're going to learn to see in these problems is that we're just simply going to write 10, because the square root of 100 is 10. So you can kind of skip that step if you need to, if you recognize that square root of 10 times square root of 10 will just equal 10. So that's step number 2. Step 3, simplify radicals in terms, simplify radical terms and non-radical terms. So we only have one radical term, that is the square root of 10. So there's really nothing we can do with that. However, we can work with the 5 and the 10. If we have the fraction 5 over 10, we know that that's the same as 1/2. So we could essentially write this as 1 over 2, and then you still have that square root of 10 frozen in the numerator. Now, typically we're not going to write that 1 there because 1 times anything is usually anything. Well, it is always everything, actually. So in this case, we would say square root of 10 over 2 is the rationalized answer for this question. So there's one of them. We're going to go through about 4 or so of these in total in this video. Really, at any point, that is the lesson at this point. So the remainder of this is just more examples. So watch as many examples as you feel like you need for the remainder of the video. So now we have square root of 3 over square root of 2. So once again, identify the radical in the denominator. In this case, it's square root of 2. That's what we need to move. That's what we need to get rid of. Remember, the goal here is not to get rid of radicals completely. It's that there's no radicals in the denominator. So we multiply by square root of 2 over square root of 2. And just as a side note, the reason why we're doing that is remember that if you multiply a number by 1, 5 times 1, 10 times 1, 100 times 1, the answer is always going to be the other number. So changing or multiplying by 1 is not changing the value of the number. When we multiply by square root of 10 over square root of 10, or in this case for number 2, square root of 2 over square root of 2, we're multiplying by 1 essentially. And that's why we're allowed to do this. Okay, so step 2 is done. Step 1 is done. Step 3, we're on 2, sorry. Mixing my step numbers up here. Multiply numerator and denominator by radical identified. Square root of 3 times square root of 2 is 6. In the denominator, we get root 2 times root 2, which is root 4, but I'm actually going to write that as just the number, not 4, but 2. So this is our answer. We can't simplify anything, so we're going to just stop there. Let's do a few more. Let's have you try number 3, actually. I'm going to have you pause the video here, try number 3, and see if you can get an answer for this one. All right, welcome back. Here's our answer. So we're going to multiply by root 10 over root 10 because that's the denominator we want to get rid of. we multiply, well, 8 and 10 don't multiply together because it's a number and a radical, so we write it as 8 root 10. Root 10 times root 10 is 100, which is just 10. So the last thing we need to do is simplify our non-radical numbers, in this case 8 and 10. That becomes 4 and 5. So 4 root 10 over 5 is our answer for 3. Let's continue to do a couple more. We're going to do, I think, 3 more in this video. So for the next one, square root of 7 over square root of 10. Once again, square root of 10 seems to be the problem here. So this process is that we're going to multiply top and bottom by that radical. In the numerator, we get square root of 70, and in the denominator, probably right now, you'll see that it's just going to be 10. Now, we have a radical in the numerator and a non-radical in the denominator. And so while we can't simplify that, the other thing that you also have learned in this lesson is that radicals sometimes can be simplified. The number square root of 70, for example, is the same thing as 7 times 10. 10 is the same thing as 5 times 2. And so sometimes what you have to look for here, it's not going to happen in this question, but what's going to happen here is you have to look for pairs of numbers. And as you can see, there's no pairs. So in this case, we actually don't have to simplify this at all. So the answer is square root of 70 over 10. So that's another thing we're going to need to look for here. And in fact, I'm going to skip number 5 and have you now look at number 6 with me on this document. So if I have square root of 5 over square root of 40, once again, we're identifying the denominator as what I need to multiply by. So when I do this, we're going to get the square root of 200 over 40. Now, in this situation, we really need to check square root of 200 to make sure that it doesn't have a perfect square. This time it will, because 200 is 2 times 100. 100 is 10 times 10. There is a pair of numbers right there. So the square root of 200 is the same thing as 10 square root of 2. That's going to be our simplified answer. So in the numerator, we'll write 10 square root of 2 divided by 40. And now we've simplified the radical. The last thing we need to do is look at those outside numbers, those coefficients, see that that's the same thing as 1/4. So we would just write this as square root of 2 over 4. So remainder of the video, we're going to just kind of have you pause the video and try a few of these out on the remaining of page 1 here. So I'm going to have you right now pause the video and try both numbers 5 and 7. 5 and 7. Pause the video, try those out, and then I will have feedback for you in just a second. Welcome back. Let's look at these two examples. So for example 5, square root of 6 was the issue, so we multiply by root 6 over root 6. Now in this case we have a 9 that is a non-radical term. We have the root 5 and the root 6, which are radical terms. So all I did was multiply the 5 and the 6 to get 30, so that 9 just stayed there, and then the denominator became 6. My last step, we took the 9 and the 6. 9 over 6 is the same thing as 3 over 2. So that's why my answer here is 3 root 30 over 2. And just also for the record, I did quickly check to see if square root of 30 simplified. It doesn't. It's only 5 times 6. There's no pairs of numbers there, even though I actually realized 6 can be 3 times 2 as well. No pairs of numbers, so we can't simplify that. So we move forward. Number 7, I got an answer of 3 root 2. Now there's a couple things going on here. First off, first step, multiply by that root 10 over root 10. Just like the last question, 2 radicals, those multiply to get the 50. The 6 doesn't multiply with anything. Root 10 times root 10 is 10 at the bottom. So now there are 2 things that we have to do here. The first thing we need to do is look at the square root of 50 and realize that that is the same thing as 2 times 5. Since there's a pair of 5s, we'll put that on the outside, and the 2 goes to the inside. Now, since there was already a 6 here from before, and then when you have a 5 now as part of the new 5 root 2 answer, that's why we're getting an answer of 30 here on the outside. Then we have our square root of 2, and in this case, square root of 2 is going to be written there instead. The final step of this question is to look at the 30, to look at the 10, and we simplify that. That is 3 over 1, which is the same thing as 3. So this is why the answer is 3 root 2. There's no fraction in this problem. It doesn't happen all the time, but in this case, it actually does. All right, you have 3 more examples in this video, so why don't you go ahead, pause for the final time here, and try those 3 problems out. I will have full answers, and we'll talk about how we got those answers in just a moment. Let's look at those answers. Let's look at number 8. So in this case, we want to get rid of the radical in the denominator, which is the square root of 8. So we're going to multiply by root 8 over root 8. We multiply like we've seen in the last problems, just those radicals together. We got that 40. We're going to go down here and test that 40, and we're going to see that it simplifies to 2 root 10. So once we've got that answer, we can substitute that back up here. Remember, there was already a 3 there before, so that's the reason why it becomes 6 root 10 instead. 6 and 8 will simplify to 3 root 10 over 4. Now, for the final two examples, the numbers were a little larger. And I want to show you a shortcut that is not really going to be important, I think, for this course, geometry, because we're going to use smaller numbers for the most part, but in future courses, it's probably a helpful shortcut. And here it is. So instead of me looking at the square root of 70 over the square root of 30, I would, some of you probably multiply by root 30 over root 30, and that means you would have gotten the number, I believe, 2100 in the numerator, and then 30 in the denominator. And look, if you get the answer at the end here of square root of 21, you actually did do the problem correct. So I'm not going to tell you that's wrong. But there is a cool shortcut that you can use, and that is when you have two radicals written on top of each other like this, you can actually write it as a single fraction like this here. So it'd be the square root of 70 over 30, which then becomes the square root of 7/3 since they both go into 10, therefore making it just root 7 over root 3. So I rewrote my question over here, and I did my work in red showing that shortcut where I wrote the simplified radicals instead. And notice the answer here involved a lot less work than trying to break down the square root of 2100. So we get square root of 21. So you don't need this. This is not a required skill for your success in this topic, but it certainly can provide less headaches when you're working with these. And here's our last question for the day. Same thing I did in the previous question. I'm going to use that new shortcut idea. So the square root of 8 over the square root of 10 is the same thing as square root of 8 tenths, simplifies to 4/5, break it down, and something cool happens with this one because the square root of 4 is actually equal to 2. So this actually made it even simpler because I have the square root of 5 that I inserted back in my denominator. The 2 was my numerator, and since there was already a 5 there, that's the reason why I have a 10. So now we're going to multiply by root 5 over root 5. We get 10 root 5 over 5, and these 10 and 5s on the outside will simplify. That's the reason we're getting 2. So this is a skill we're going to continue to work on, and it will continue to be embedded in our lessons in the near future. You now have a chance to practice a few of these additionally on your own. Thank you for watching.